Today we're going to look at the MIT 2023 Integration B final question, problem number 4, which is the floor function of 10 to the power 20 integral from 2 to infinity of x to the power 9 over x to the power 20 minus 48 x to the power 10 plus 575. So first, I think it'll be up to try and discuss what a floor function is. A floor function is a function that extracts the floor of a number. For example, if you have a number 1.5, the floor of that number is 1, as opposed to rounding, which would give us 2. This truncates the number and you get the lower integer. So for example, 1.6, the floor of that would be 1. 2.3, the floor of that would be 2. At 2.8, the floor of that would still be 2. Now, if you go to the negative side of things, if you had, for example, the floor of negative 0.5, that would be equal to negative 1. It goes to the integer lower than the number. And for example, the floor of, for example, 2.5 negative would be equal to negative 3. Okay, so it won't be negative 2, so it will be negative 3, and that's the integer lower than that number. So going ahead, first we would have to look at the integration of x to the power 9 over x to the power 20 minus 48 to the power x times 10, x to the power 10 plus 575 from 2 to infinity. So we can go and expand the x to the power 10 term, and that is the same as 23x to the power 10 minus 25 x to the power 10. And so if we go further to factorize that number, we pull out the x to the power 10 term on the left hand side, and you're left x to the power 10 minus 23. And on the right hand side, if you pull 25 out, we're left with x to the power 10 minus 23. So easy to factorize that out, and that is x to the power 10 minus 25 times x to the power 10 minus 23 on the denominator side. So we can further isolate the x to the power 9 numerator, and then separate the two fractions, and so you're left with half times 1 over x to the power 10 minus 25 minus 1 over x to the power 10 minus 23. So you can take back the x to the power 9 inside, and as you can look at that fraction, you can clearly see that the integral of those independent fractions would be the natural logarithm of absolute x to the power 10 minus 25. So as you can see, as I mentioned previously, the integral of the first fraction is 1 over 10 logarithm of x to the power 10 minus 25 absolute minus 1 over 10 log x to the power 10 minus 23 absolute from 2 to infinity. So multiplying half by 10, we have 1 over 20, and then substituting in for the limits, you have log of infinity to the power 10 minus 25 minus log to the power 2 of 2 to the power 10 minus 25 absolute minus log infinity to the power 10 minus 23 absolute minus log 2 to the power 10 minus 23 absolute. So as you can see, the infinity to the power 10 goes to infinity, on both sides, and the infinity values definitely could just um, cancel out. And now we are left with 1 over 20 log to the power 10 minus 23 absolute minus log to the power 10 minus 25 absolute. And so this is a logarithm of 1024 minus 23 minus log 1024 minus 25, which is 1 over 20 times log 1001 absolute minus log 999 absolute. You can express that as 1001 over 199 log. So if we pull 1000 out and we express the numerator and denominator as a sum and subtraction respectively, you have 1000 for the numerator times 1 plus 1 over 1000, and for the denominator inside the logarithm function, it's 1000 times 1 minus 1 over 1000. And the thousands could cancel out, and so you're left with 1 over 20 logarithm of 1 plus 1 over 1000 over 1 minus log 1000. So if we take the Taylor expansion or the Mark-Lorentz expansion, natural logarithm 1 plus x, this is the same as x minus x to the power 2 over 2 plus x to the power 3 over 3 minus x to the power 4 over 4 and so on. And log 1 minus x is the same as minus x squared over 2 minus x cubed over 3 minus x to the power of 4 and so on. So that if you have logarithm or natural logarithm of 1 plus x over 1 minus x, you subtract the first value, you subtract the second value from the first value, and so you're left with 2x plus 2 x to the power 3 over 3 plus 2 x to the power 5 over 5. This is 5. And this now implies that if you have our 1 over 20 log 1 plus 1 over 1000 over 1 minus 1 over 1000, we can substitute the smaller value there into the x. And as you can see, this results in 1 over 10 times 10 to the minus 3 plus 10 to the minus 9 over 3, 10 to the minus 15 over 5, 10 to the minus 21 over 7. We can now substitute the answer from the previous answer, where now we can multiply 10 to the power 20 times 1 over 10 times 10 to the minus 3 plus 10 to the minus 9 over 3 times plus 10 to the minus 15 over 5 plus 10 to the minus 21 over 7. So that gives us the answer, which is first of all 10 to the power 19 times again 10 to the minus 3 plus 10 to the minus 9 over 3, 10 to the power minus 15 over 5 plus 10 to the minus 21 over 7. So we can now reduce that into 10 to the power 16 plus 10 to the power 10 over 3, 10 to the power 4 over 5, 10 to the power minus 2 over 3. So 10 to the power 16 can be expanded as shown here, and also 10 to the power 10 over 3 becomes 33333, 10 times 0.333 plus 2000, which is 10,000 divided by 5, and then the fraction 0.033 results from 10 to the power minus 2 over 3. So as shown here, the answer now becomes that 0.3366. We can now truncate the decimal values to obtain the flow, which is 10 100,000,033,33,33,53,33 as our final answer. Thank you very much for your kind attention. It's been fun really trying to solve this question. Please subscribe to our channel in order to get some of the very interesting solutions to some of the very intricate problems that we come uh, that come our way. Thank you.